Hi there, welcome to the trigonometry module. In this module, we discuss measurements in a triangle, which is what trigonometry means. It means measurements in a triangle. Now, what are you measuring in a triangle? We're going to discuss those. But before we do so, first of all, let's talk about the triangle. You've heard of the triangle, is the three-sided polygon, and there are different types of them. You have the right triangle. That is a triangle that has a 90 degree in one of the corners. That's one of the angles in the triangle. That is called the right triangle. And that angle is called the right angle, the 90 degree angle. If you add all the interior angles of any triangle together, you will get 180 degrees. So the sum of the interior angles of any triangle is said to be supplementary. That is, they add up to 180 degrees. So that will be true for a right angle triangle. Or an isosceles triangle, that is a triangle that has two sides equal, and also that means the two angles will be equal as well, as my picture indicates here. Similarly, if you add all the interior angles together for an isosceles triangle, you will get 180 degrees. And also there is the equilateral triangle. That is a triangle that has all its sides and all its angles equal. And since all the angles are equal and all those angles must add up to 180 degrees, that means that each of them will be 60 degrees in size. That's for an equilateral triangle. And then you have the scalene triangle. That's just a triangle that does not have any side equal and any of the angles are not equal as well. But if you add all the interior angles together, the same thing will be true. They will be supplementary. They will add up to 180 degrees. Now, all these triangles that we've talked about, except the right angle. So you either have a right angle triangle or what you call an oblique triangle. That's a triangle that does not have a right angle in it. So if your triangle has a right angle in it, that is a 90 degree angle, you say it's a right triangle. And if your triangle does not have a right angle in it, you say it's an oblique triangle. Now, we said trigonometry deals with the measurements in a triangle, and we have been talking about triangles. Now, let's talk about the measurement. What do we measure in a triangle? We measure the corners, in other words, the angles, and we also measure the length of the sides in the triangles. We are going to learn how to do that in trigonometry. And when we measure the corners, we measure the corners in degrees or radians. And the length of the sides, we measure in centimeters, millimeters, meters, kilometers, if it's a really big triangle, and so on. And a picture corresponding to that might look like so. You have a triangle, and there's an angle in there. That symbol is called theta, by the way. It's theta. It's a Greek symbol. We're going to see some Greek symbols here, mainly theta. And you have the length of the sides x, y, and z. Now, for us to do trigonometry properly, we need to introduce the Cartesian plane, which you may have seen before. The Cartesian plane is just two-dimensional, and it's made up of two copies of the real number line. We talked about the real line in module 1. That is the line that contains all the real numbers. So if you take two real lines and you cross them as shown, you will get the Cartesian plane. It's a Cartesian coordinate system. The horizontal real line, you say that is the x-axis, and the vertical real line, you say that is the y-axis. Together, you say this is the Cartesian plane or the Cartesian coordinate system, the xy coordinate system. Now, this xy coordinate system is such that every point in the plane can be identified as an ordered pair. So, for example, like I've shown here, if you pick any point in the plane, you can label it x, y. X for the x coordinate, the x value on the x-axis, and y for the y value on the y-axis, and together you write x, y. And this is called an ordered pair. It's not y, x, it's x, y in that specific order. X always comes first, followed by y. Also, this Cartesian plane, you label in this order. So they are in 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4 in that order. Now, for example, here is a Cartesian plane, and I've kind of labeled 1, 2, 3 on the x-axis, and on the y-axis as well. Now, where the two real number lines, where they cross one another, that point is called the origin. That is the 0 point, okay? That the coordinate, the ordered pair for that point is 0, 0. And so from there, you can label 1, 2, and 3 to the right, and -1, -2, -3 to the left on the x-axis. And similarly on the y-axis, you can label 1, 2, 3 upwards on the y-axis from 0, and downward -1, -2, and -3 as well. So we can identify some points now. The point 2, 1, you can see where that would be. 2 on the x-axis and 1 on the y-axis. That will be that point. It's an ordered pair. Similarly, the point 3, 3, we can identify in a similar way. Or -3, 1, so -3 for x and 1 for y. And you can also identify 3, -1, 3 for x and -1 for y in there. Now, having said that, now we're ready to talk about the measurement of angles. Okay, so we're going to draw angles in what we call standard position. That's what we're going to do here, and I'm going to show you how to do that. Now, first of all, when you measure angles in the Cartesian plane for trigonometry, the right side of the x-axis, that is where we begin. It's called 0. That's 0 degrees. And angles are measured counterclockwise. That is the positive angles, like I've shown here. So if you want to measure a positive angle, you start from the x-axis, the right side, and you measure counterclockwise. That would be a positive angle. And you measure from 0, you go up to 90 degrees, and then to 180 degrees, to 270 degrees, and all the way around back to 360 degrees. And you can do that again, right? 360 degrees, and then you have 420 degrees. You can go to 500 degrees and keep going all around, or to 720 degrees and so on. Now, you can also measure angles in the clockwise direction. Now, the angles that you measure in the clockwise direction are the negative angles. So if you start from the 0 degrees, which is the right side of the x-axis, and you go clockwise, like I've shown here, you will get to -90 degrees, -180 degrees, -270 degrees, -360 degrees, and so on. For example, let us measure 30 degrees. Let us draw 30 degrees in standard position on the Cartesian plane. So we have 0 degrees and we have 90 degrees in there. And you know that since it's 30 degrees, 30 degrees will be between 0 and 90 degrees. So therefore, we will start from the right side of the x-axis. We will call where we're starting from the initial arm of the angle, and we'll draw that angle in there. You can see the terminal arm of the angle. That's where the angle ends, and we'll label that angle in there. You can see that I've labeled that 30 degrees. So you have the initial arm, that's where you start. Where you end the angle is called the terminal arm, and you can see my picture there. That angle 30 degrees is in standard position. Let's draw another one, 120 degrees. We do the same thing by starting in the right side of the x-axis, and since 120 degrees is more than 90 degrees, we know that it will be between 90 degrees and 180 degrees. So the terminal arm will lie in quadrant 2, like I've shown here. So you can see my angle there is 120 degrees. That is my angle in standard position. We can also draw 300 degrees. We will start on the at 0 degrees on the right side of the x-axis, and we'll draw that angle in the counterclockwise way. We'll draw it all around in that way. You can see the angle, the terminal arm will be in quadrant 4, and you can see my 300 degrees is sitting right over there. That is my angle in standard position. Now, what do we mean by reference angles? That's the final thing we're going to talk about here. Let us find the reference angles for 150 degrees. I will illustrate what a reference angle means by using examples. To find the reference angle of 150 degrees, the first thing is to draw that angle in standard position, like we had done before. So 150 degrees in standard position will be as shown, right? 150 degrees is between 90 degrees and 180 degrees, and if we start from 0, we can just rotate, and we'll have that angle in standard position in that way. Now, the angle formed between the terminal arm and the horizontal side, and 180 degrees, right? This is the horizontal arm in the Cartesian plane. That angle is 30 degrees. That angle is called the reference angle of 150 degrees. So whenever you are looking for reference angles, they are always formed with the x-axis, either to the left of 0 or to the right of 0. In this case, because 150 degrees is in quadrant 2, it borders the left side of the x-axis. So 30 degrees will be the reference angle of 150 degrees. Now, how do we find the 30 degrees? 180 degrees is more than 150 degrees, so we just subtract 150 degrees from 180 degrees to get 30 degrees. Let's look at 250 degrees. 250 degrees in standard form is as shown. If you rotate from 0, right, you will get to 90 degrees and 180 degrees, and then you get to 250 degrees. Just before you get to 270, you get to 250 degrees. The reference angle is the angle formed with the x-axis. What is that angle? Well, we will just subtract 250 degrees. We subtract 180 degrees from 250 degrees. So 250 degrees is the big angle. So we subtract 180 degrees, we get 70 degrees. Therefore, the reference angle of 250 degrees is 70 degrees. What about 340 degrees? We can draw 340 degrees in standard position as shown. The reference angle is the angle formed with the x-axis, like that. See, that angle is the reference angle. And what is that angle? Well, if you keep going from 340, you get to 360 degrees. 360 degrees is bigger than 340 degrees, so we can subtract 340 degrees from 360 degrees. We get 20 degrees. That is the reference angle of 340 degrees. What about negative angles? We can also draw negative angles on the Cartesian plane. Like we said previously, those are measured in the clockwise direction, also from 0. For example, let us draw negative 310 degrees in standard position. If we start from 0 and it will measure clockwise, we just measure like you go from 0 to negative 90 to negative 180 to negative 270, and we'll end up at negative 310 degrees in the first quadrant. The reference angle of negative 310 degrees is the angle that borders the terminal arm with the x-axis. And you can see, as I've shown it in there, the measure of that angle will subtract the smaller angle from the bigger angle. The bigger angle is negative 310 degrees. So negative 310 minus negative 360 degrees will just give you negative 310 plus 360 degrees, which will be 50 degrees. So the reference angle of negative 310 degrees is 50 degrees. So even though the angle is negative, the reference is still positive, right? It is still 50 degrees. So even whether your angle is positive or negative, the reference will always be positive. Or negative 155 degrees. What is the angle in standard position? Well, it will be as shown. We'll start from 0 and we'll measure that angle in the clockwise direction because it's a negative angle. And we can draw in its reference. The reference is the angle formed with the x-axis, and the measure of that angle we will just subtract. Negative 155 is the big angle. We subtract negative 180. The result will be 25 degrees. So you try now and try your hand on these examples here, and like we've done in the previous modules, please pause the video now, and when you're done with these examples, you can continue the video to see what I have done. So please pause the video now. So what did you do? Well, here is what I have done, where you are supposed to find the missing angle in this first triangle here. I've labeled that angle X. So we know that the sum of the interior angles in any triangle is 180 degrees. So you can just solve for that angle, you will get 115 degrees. Similarly, for the second triangle, I've labeled that angle theta, the missing angle, and you have a right triangle here, so you know that that angle is 90. So if you add all those angles together with the missing one, you will get 180 degrees. You can solve for the missing angle, and your result will be 45 degrees. Look at this angle here, 80 degrees. In standard position, you can see it will be the rotation from 0, and it's in the first quadrant. And that angle, 80 degrees itself, is the angle formed with the x-axis. So 80 degrees is its own reference angle. 278 degrees is not quite like that. You have to draw the angle, go counterclockwise, and the angle ends up in quadrant 4. And the reference angle is the angle that formed with the x-axis. That angle is 82 degrees. And finally, you have negative 100 degrees, a negative angle. You measure negative angles in the clockwise direction. That angle will be in quadrant 3, and its reference angle is the angle formed with the x-axis on the left side of 0. And if you subtract negative 180 from negative 100, you will get 80 degrees. So the reference angle of negative 100 is 80 degrees. So this concludes the first part of trigonometry.